So now let's start with this another topic, which is cube roots of unity. Now what do I mean by cube roots of unity? Let's say if I have a complex number where z cube is equals to 1. Now of course I know since we have z cube equals to 1, what we used to do till now, we used to assume that z is equals to 1. We used to call this only as our answer, right? However, since it is a cube, that means it is going to have 3 roots, alpha, beta and gamma. Since it is a cube root, it is going to have 3 roots in it, right? So there are 3 roots. Till now we used to talk about only alpha, which we considered as 1. So because it is the only real root that we are going to get. Now what if, let's say if I take the 1 to the other side, and from this equation, if I take z minus 1 as common, if I take z minus 1 common, I would be left with z square plus z plus 1 is equals to 0. From here we used to say that we are going to get 1, which is the real number. However, now from this equation, we can also have 2 complex roots or 2 imaginary roots for this equation as well, which we call as the omega and omega square. So remember this thing, if you have, let's say, any cubic type of root, it is going to have 3 basically the roots. One is going to be your real one, which is 1. The other one is going to be omega, and the third one is going to be omega square. And now, of course, since I know this is my quadratic equation, if I try to solve it, and whatever, let's say, negative value I get inside the square root, if I try to replace it with iota, what are the exact roots that I'm going to get? My complex roots, omega would be minus half plus root 3 by 2 iota, and omega square would be minus half minus root 3 by 2 iota. So keep this thing in mind. Whenever you see cube roots, there are going to be 3 roots. One is going to be a real one, and the 2 of other roots are going to be complex. Now you must remember what is the value of omega and what is the value of omega square. So basically, if you try to look at these two, omega and omega square, one thing that you can see is that omega is basically the conjugate of omega square, right? Because minus half, the real part is same in both these roots. However, the imaginary part in one of them is root 3 by 2. However, in the other is minus root 3 by 2. That means these two are basically conjugate of each other. So omega and omega square are conjugates. So keep this thing in mind. Now, one more additional information that I must tell you. From here, we know that z square plus z plus 1 is equals to 0. This has 2 roots. One is omega and one is omega square. Now what if sometimes in the question you have been given z square minus z plus 1? If let's say you have a minus z here, what would be the roots of this equation now? It would simply be minus omega and minus omega square. So these are going to be 2 roots of this equation. So keep these things in mind. Now let's look at a few properties, relation between these 3 roots. Now let's say if I multiply all these 3 roots, 1, omega and omega square. If I multiply these 3 roots, I'm going to get omega cube, which is equals to 1. Keep this thing in mind. And if I add all these 3 omegas, all these 3 roots, I'm always going to get 0. So from here, one thing that I can make out is that how can I write this equation in the other format? This can be written as omega square plus omega, and 1 can be written as omega cube, because omega cube is always equals to 1. So I can write it down in this format. So from here, what is the conclusion that we are making is that if we have 3 consecutive powers of omega summed together, then it is always going to be 0. Omega to the power 3n plus 2, this is always going to be 0. Like we had studied for iota as well. We had studied that if we sum 4 consecutive powers of iota, we are going to get 0. However, for omega, if we sum 3 consecutive powers, we are always going to get 0. Now, one important property that you must remember is that this 1 omega and omega square, this is basically are in GP. Now, how do I know they are in GP? Because if you look at the middle term, omega, if they are in GP, that means my middle term square would be equal to the multiplication of first and last term. So my middle term is omega. If I write the square of it, it is going to be omega square. It should be equal to omega square into 1. So they are equal. So it is basically in GP. Now another important point. This is a very important point that you must remember. Now let's say if I plot, upon plotting 1 omega and omega square on the Argand plane, if I plot these points on the Argand plane, I am going to get, it would be an equilateral triangle. Keep this thing in mind. It is going to be an equilateral triangle whose side length is root 3. So of course you can try it out by yourself. Let's say this is my graphical structure. I'm going to have my 1 somewhere here, my minus half plus root 3 by 2 iota. Where is it going to be? It is going to be somewhere here. And the other one, omega square, it is simply the conjugate of it, so it is going to be somewhere here. So if I join all these 3 points, I'm going to get an equilateral triangle of side root 3. So keep this thing in mind. This is perpendicular to my real axis. Apart from that, a few more properties. Let's say if I have omega into omega square, it is always going to be 1. If I have omega square into 1, it is going to be 1. So the order of multiplication does not matter. Powers, omega to the power 4 would be omega, because I can write down my omega to the power 4 as omega cube into omega, and omega cube is 1. Similarly for omega to the power 5 as well. So the powers of omega cycle after every 3 steps. So the cube roots of unity are represented as points on the complex plane, forming the vertices of an equilateral triangle inscribed in a unit circle. So now if I try to form a circle with the center as origin, if my origin is center, if I try to make a circle, it is going to be this in this format, where the radius of this circle is 1. So keep this thing in mind. The angle between 1 and omega and between omega and omega square is 2 pi by 3, which is 120 degrees. So of course, by looking at the diagram also, you can see if this is an equilateral triangle, that means all sides are going to be 60 degrees. And if I see 1 and omega, at what angles are they? My 1 is at a 0 degree angle, and my omega is at basically at some angle here. So what is my angle? How do I measure my angle generally? It is measured in this format, right? So whatever angle I get from here, I'll have to subtract this 30 from here, 30 degrees from here. So based on that, I'll get my angle to be 120 degrees. So of course, by the diagram also, you can find out whatever are the angle differences between all these points. So now let's look at a question based on this. So we've been given z is equals to root 3 by 2 plus iota by 2. So whenever you have been given your complex number in this format, where you can see root 3 by 2 and 1 by 2, try to convert it into the omega format or in the cube root of unity format. So we know that our cube root of unity, one of them used to be minus half plus root 3 by 2 iota, and the other one used to be omega square is equals to minus half minus root 3 by 2 iota. Now in my z here, I can see that both the terms are positive and my iota has been replaced. Now my half has the iota and my root 3 by 2 is the real part. So how can I try to convert my omega and omega square in this z format? If I multiply my omega with minus iota, wouldn't it simply transform into this format, z? So yes, this can be written as minus iota into omega. Or let's say if I was to convert omega square into this format, how can I convert it? Omega square, I'll need to multiply with a plus sign, then I'll multiply with an iota. However, I'll get a minus sign in the root 3 by 2. So omega square cannot be used. Basically, I can only use my omega. So if I multiply this by my iota into omega, if I multiply this with iota and then multiply with a minus 1 as well, wouldn't this become the z that we are trying to find out? So basically my z is minus iota omega. Now whatever they've asked us, let us try to replace these values of z in that equation and find out the answer. So what would be the values after replacing? This would become 1 plus iota into minus iota omega plus minus iota omega to the power 5 plus iota times of minus iota omega to the power 8 whole to the power 9. So from here I'll have 1. This would become iota into iota minus 1 into minus 1 plus 1. So this would become plus omega. Here I would have a minus sign outside. Iota to the power 5. What is iota to the power 5? iota to the power 5. It is going to be iota to the power 4 into iota. This is simply 1. So this would become iota. So this is going to be iota as it is. And I would have omega to the power 5. What is omega to the power 5? This can be written as omega cube into omega square. And omega cube is simply 1. So omega 5 is omega square. So this becomes minus iota omega square. Plus here I have minus. So this minus would be removed because I have an even power now. Since this is an even power, I have iota to the power 8. It is always going to be 1. It is a multiple of 4, right? And what is omega to the power 8 going to be? It is going to be omega to the power 6 into omega square. So this would become 1. So omega to the power 8 is basically omega square. So here again, I am going to have iota omega square whole to the power 9. Now this and this term can get cancelled out. And what are we left with? 1 plus omega to the power 9. Now I hope you all remember that we had studied 1 plus omega square. This used to be equal to 0. So from here I can say that my 1 plus omega would be minus omega square. Now I can replace this value here. So this would become minus omega square to the power 9. So this would become minus omega to the power 18. And omega to the power 18 is a multiple of 3. That means I can write it as omega to the power 3 and 3 into 6. So basically it is 1. And from here we get our answer to be minus 1. So this is how you can solve questions whenever in any complex number. If you see root 3 by 2, 1 by 2, try to convert it into the cube roots of unity so that your solving of question becomes much easier. Let's look at one more question. Here again, they've given us the equation x square minus x plus 1 is equals to 0. Now here they've told us that alpha beta are the roots of this equation. I hope you'll remember we had studied that z square plus z plus 1 is equals to 0 had the roots omega and omega square. However, whenever we used to have z square minus z plus 1 is equals to 0, it has roots as minus omega and minus omega square. So similarly, I can consider this equation z in the x format as well. So this omega is basically my alpha and this beta is my minus omega square. So now I need to find out the value of alpha to the power 101. So this is minus omega to the power 101 plus beta minus omega square to the power 107. So from here what do we get? This would become minus, this would simply become omega square plus, sorry, here also I would have a minus, this would become omega. This simply transforms into 214. And what is 214? 214 is omega. I can write down omega to the power 214 as omega to the power 3 times of x plus 1. Whatever this x is, let's say this x is going to be 71. So I can write it down as 3 into 71 plus 1. So this 3 into 71, this would transform into 1 and I would be left with just omega. So this would become this. Now this is what I've gotten after solving alpha to the power 101 and beta to the power 101. And from our cube roots of unity, we know that 1 plus omega square is always equals to 0. So 1 can be written as minus omega square. So here I have minus omega square minus omega. So this is simply 1. So this is how we solve questions related to cube roots of unity. Now let's talk about locus. Of course, we've done a lot of locus finding when we were studying coordinate geometry. Then we did 3D geometry as well. There we studied a lot of locus. Now we'll be seeing at a few standard formats. Now, of course, whenever you have a complex number and you need to find out the locus of whatever conditions has been given in the question, the best format for you is to assume that your z, for which you have to find out the locus, as x plus iota y, and then try to satisfy the conditions that have been given in the question. From there you will get your locus. Apart from that, sometimes what happens is I'll give you a few standard equations now which would be recommended for you to remember, so that whenever in questions if you see the such type of standard equations for locus, you can directly substitute and understand that, oh yes, this is the locus of a circle, this is the locus of an ellipse. So I'm just going to give you 4 different standard locus formulas that you need to remember. Again, you can definitely try and prove them by yourselves. You can assume your z to be x plus iota y and then replace all the values and find out your answer. I'm not going to go into the proof because it is not in your syllabus. This is just a shortcut trick for you to remember how you can find out your locus. So first one, before I start, first and few things that you need to remember is, let's say if I have a fixed point given, which is P, Z1, let me assume. P is a fixed point that has been given. And there is another fixed point, Q, Z2 given. So these 2 points are my fixed. They have been given in the question. And now the point for which I have to find out my locus, I'm assuming it to be, let's say, H. This is my general, for which locus has to be found out, for which locus needs to be calculated. And I'm also going to assume a constant K, which is a constant basically. So now I will start writing down the standard formats here. Let's say if in a question you see a format which is Z minus Z1 is equals to K times of Z minus Z2. If you see in a question which is in this format, then from here what you can say is that if there are going to be 2 cases here, if let's say K is not equal to 1, then it is going to be a circle. And if K is equals to 1, what we can say is that Z, which is the locus that we are finding, is the perpendicular bisector of P and Q. Z locus is the perpendicular bisector of P and Q. So that means if I have my, let's say, Z1 point in the Argand plane here, I have my Z2 point here in the Argand plane. That means if my K is equals to 1 and it is in this format, then where is my H locus going to be? It is going to be in the perpendicular bisector of P and Q, which is going to be a straight line, vertical line, which is joining Z1 and Z2, perpendicular to Z1 and Z2. So keep this thing in mind. This is one of the standard format that you must remember. Now another standard format that I'll show you. Let me star it here. Again, if you do not remember this, it is not that you wouldn't be able to solve questions of locus. You can definitely put Z as x1, y1 and your z1, whatever has been given to you in the question, substitute the values. You are going to get an equation which is in x and y format. You can find out what your circle's equation is, what your perpendicular bisector's equation is. So that can also be done, but this is just for you to save time during your examination. Let's say you have an equation which has no fixed points in it. The only thing that has been given is z plus z bar plus, this is modulus, z minus z bar, and this is equals to k, let's say. Now of course the k value does not determine anything here. Whatever be the values of k, this is always going to signify that this is a locus of a square. So it is going to be a square. So z plus z bar plus z minus z bar modulus. So another important locus you must remember. Now let's look at 2 more standard formats. Let's say if you have z minus z1 minus of z minus z2, and this is equals to k. And here what I am defining is that my k, for my 2 cases, what I am defining is that one case where my k is not equal to z1 minus z2, and the other case where my k is equal to z1 minus z2. If let's say my k is not equal to z1 minus z2, then this is the locus of a hyperbola. And if k is equals to z1 minus z2, this means that my locus or my z lies on the line PQ. That means if let's say my P is here, my Q is here, there is a line joining PQ, right? So if k is equals to z1 minus z2 and I have the equation in this format where I have z minus z1 minus z minus z2, then my locus of z would be lying in the same ray only. It is going to be lying in the ray or line joining P and Q. So another important result. Let's look at the final and one more. Let's say if you have z minus z1 and here there is a plus now, z minus z2, and this is also equals to k. Now again, if let's say I have k not equal to z1 minus z2, then this is going to be the locus of the ellipse. And on the other hand, if k is equals to z1 minus z2, then this is going to be the locus of line joining my points p and q. So this is going to be line joining p and q. So simply it is going to be the line that is joining. It is not going to lie in that line. It is going to be the line that is joining. So I hope you are understanding the difference between this one and this one. Here I was telling that it is going to lie in that line. That means if let's say my q point is here, my p point is here, this is the line joining them, right? In this case, in the first case, my locus can lie somewhere here as well. However, in this case, if p and q are the points here, this is the line joining them. So this line which is joining them, this is only exactly the locus that we are talking about. So keep this thing in mind. If you see such standard formats, you can directly write down the answer that it is going to be the locus of a circle, it is going to be perpendicular bisector. Else you can still solve your question by assuming z to be x plus iota y and then solve the question. We have an example taken after this slide. There we will see how, if let's say we are not being able to identify any standard function, then how can we solve the locus. So first let's look at this question. They've given us modulus z is equals to 2 and they've given us a standard equation. Now here you can see that it is a standard equation. How can I write this equation as? This can be written as z minus iota is equals to z plus 5 iota. And I hope you all know, for this type of standard equation, I used to assume a k here. Or if I write that type of equation down, my standard equation that we studied, it used to look somewhat like this: z minus z1 is equals to k times of z minus z2. So if I try to compare with this equation, what is my k? My k is 1, my z1 is iota, and my z2 is minus 5 iota. So my k is 1 here. That means what is my locus going to be? So I know that if k is equals to 1, that means my locus would be the perpendicular bisector of z1 and z2. So my locus would be perpendicular bisector of z1 and z2. So if I try to draw my z1 and z2 in the Argand plane, my z1 is going to lie somewhere here, which is going to be iota, which is going to be 1, and my z2, which is minus 5, it is going to be somewhere here. Right, now I'm plotting my z1 and z2. So this is my z1, this is my z2. So my locus is basically the perpendicular bisector of z1 and z2. So what would be the perpendicular bisector if you look at this carefully? It is going to be somewhere here, which is minus 2. Right, so this line is my locus. I hope you are understanding this, why I wrote minus 2 as my locus. This is minus 2. This is the z that we are trying to find out. So that means the z that I am finding, my locus would be minus 2 iota. Now if let's say they had given us z is equals to x plus iota y. So from here what I can say is that my x is equals to 0 and my y is equals to minus 2. So this is how you find locus. Now since we knew that this was a standard format, it became very easy for us to solve, right? Let's say if we didn't know, then we would have to replace x and y in the equation, then segregate the real part together, segregate the imaginary part together, then find out the modulus. So that is how it would become for us to solve. Let's look at this question. Now in this question, of course, you can see that there is no standard format that you can find out. Here they've given us that the real part of z minus 1 upon 2z plus iota, this is equals to 1. So now again, there is no standard format here, so we have to replace x and iota y. So in this equation, if I replace my x and iota y, so this would become x minus 1 plus iota y. I'm directly segregating all the real parts together and the imaginary parts together. And below I am going to have 2x plus iota times of 2y plus 1. So this is going to be my equation basically. Now what I'll do is I'll multiply the denominator by 2x minus iota times of 2y plus 1, numerator as well 2x minus iota times of 2y plus 1, so that I can remove the complex number from the denominator. So from here what do we get? This would become 2x times of x minus 1. Sorry, let me write it down directly. So this would become x minus 1 into 2x plus iota y into 2x minus plus x minus 1 into minus iota 2y plus 1 minus plus iota y into minus iota 2y plus 1. So this is what we will get in the numerator, and in the denominator we are going to have 4x square. This iota square would become minus 1, so we would have a plus here. This would be 2y plus 1 whole square. Now they've told us that for this entire function the real part is equals to 1. Now I'll simply segregate the real part and leave all the imaginary part aside. So what would be the real part in this equation? So my real part would be 2x into x plus 1, x minus 1. And what would be my other real part? It would be iota into iota minus 1. With multiplied with minus it becomes plus 1. So plus y times of 2y plus 1 upon 4x square plus 2y plus 1 whole square. So this is my real part. This is basically my real part, right? So this value is equals to 1. Now let me try and solve this out. What is the locus, or what are the equation of related to x and y that I'm getting? So if I solve this, this would become 2x square minus 2x plus 2y square plus y. This would be equal to 4x square plus 4y square plus 1 plus 4y. So now if I segregate all these terms together, what am I going to get ultimately? This would become 2x square plus 2y square. Here I would have a plus 2y plus 3y plus 1 is equals to 0. So if I remove the 2 from the coefficient of x square and y square, so I would get x square plus y square plus y plus 3 by 2 y plus 1 by 2 is equals to 0. So this is the equation of a circle. So this is exactly what my locus is. So my locus of z is a circle. Now I can find out the details about this circle as well. So what is going to be the center of this circle? The center of this circle would become minus g comma minus f. Sorry, this is not y, this is x here, sorry. This is 2x. So this would become x simply, yes. So what is my g? My g is simply half. So my center would become minus 1 by 4. Sorry, my g is actually my g is basically 1 by 2. So minus g would become minus 1 by 2, and my f is 3 by 4, so it would become minus 3 by 4. So this is the center of the circle. And what would be the radius of this circle? It would be g square plus f square minus c. And upon solving this, what do we get? We get root 5 by 4. So this is my radius, this is my center, and the locus is basically a circle. So if I draw it in the Argand plane, so my center is going to be minus half comma minus 3 by 4. So it is going to be somewhere here, and this is what my circle would look like. So this is my locus. So this is how you solve questions related to locus whenever, let's say, a standard form is not given. The only way to solve is replace the values x and y, then try to solve the equation, get an equation in terms of x and y, try to identify using the standard format as to what locus it is or what geometry it represents. From there you will get your answer.